In section 7.7, we're going to look at graphing some inequalities by hand. But these are going to be linear, quadratic, all sorts of inequalities that we'll be graphing by hand. If you remember from previous math courses, our linear inequalities will have inequalities in them, meaning a less than or equal to, a greater than, or a greater than or equal to. We'll first look at graphing the actual shape, whether it's a straight line or parabola, whatever it is. Then we'll work on whether or not it's supposed to be a solid line or a dotted line. It's going to be a solid line if we have the equal to on either a less than or equal to or a greater than or equal to. That's when you have your solid line. But if it's just a strictly less than or strictly greater than, then that's when we have a dotted or dashed line. Now, besides drawing a solid or a dashed line, you also have to shade one side of your graph. Again, I say line because that's what we're going to start out with, but we have to also shade one side of your graph. How do you figure out which side to shade? You choose a test point and you see if it works. If that point works, you're going to shade that side of the line. If the point doesn't work, then you're going to shade the other side of the graph that the point is not on. That's if the point doesn't work. Huge minor detail is that you have to choose any point that is not on the graph. So we can pick any point we want, and we want to choose the nicest point we can choose, but it needs to make sure that it is not on the line. Then, like we said, if the point satisfies the inequality, making it a true statement, we'll shade that side of the graph. If the point doesn't work, then you actually shade the other side of the graph that the point is not on. Let's take a look at this first graph. On this first graph, we have y is greater than or equal to x plus 2. This is a line. How we know it's a line is because it's in the form y equals mx plus b, which means that whatever's in front of your x is your slope. Well, I don't see anything there, so it's a hidden 1, which means that my slope, my m, is equal to 1. And what else do we know? We also know that our b, our y-intercept, is a 2. So that means our b, our y-intercept, is equal to 2. Now, remembering way back when from previous math classes, how do you graph something that's a line that's in slope-intercept form? Well, remember that you start out with your y-intercept. It's where you'll intersect the y-axis at, according to this, 2. So we'll go up to 2, and that's where we'll intersect the the y-axis. Then we said our slope, m, is 1. Well, remember, we like to think of our slope as a rise over a run. Well, what's underneath the 1 if you don't see anything? Well, remember, then it's also going to have a hidden 1 on the bottom. Anything can be rewritten as itself over 1. Which means because the rise over run, the slope is positive, what we can do is the rise is 1 means we'll go up 1, and the run being positive means we'll go right 1. So up 1, right 1. So that means from our y-intercept here at 2, we're going to go up 1 and then right 1. And that gives us a map to our second point. And you could keep on doing this, going up 1 over 1, up 1 over 1, up 1 over 1 to get more than 2 points. But all you need as a bare minimum is 2 points. Once you have your 2 points, you can draw your line. But remember, we have to stop. What kind of line is it? Well, the fact that we've got a greater than or equal to symbol The equal to tells us that we're going to draw a solid line. So when I draw my line here through the points, it's going to be a solid line. It doesn't have to be perfect, but that's the idea. Now the question is, which side of my graph am I going to shade? Well, I need to pick a point, any point, and I need to test it by plugging it in. Well, I'm going to pick the easiest point I can think of right here in the middle, 0, 0. It's okay to use this point because it does not go through the graph. What does it mean to actually test? So we're going to test 0, 0. That means that we're going to plug in 0, 0 and see what happens. So we're going to plug it in. It means we're going to plug in 0 for y and 0 for x. So we're going to plug in 0 for y and 0 for x. So that will give us 0 is greater than or equal to 0 plus 2. Well, if we go ahead and simplify, the left-hand side is 0 is greater than or equal to 0 plus 2 is 2. So let's read our statement here. Is 0 greater than or equal to 2? And the answer is no, it is not. This is not true. So what I'm going to go is go to my graph where 0, 0 is, and I'm going to put a little X. That point doesn't work. If the point we test doesn't work, that means we're actually going to shade the other side of the graph that this point is not on. So that means I'm going to go to the other side of the graph and shade that side instead. And that's going to be my final answer. If you go to graph these in MyMathLab, you'll graph them like you would a normal line. You'll pick the line tool. You'll select solid instead of dotted. And then there's this little tool that looks like a paint bucket. And what you would do with your paint bucket is you would click somewhere over here, and it would go ahead and just paint that entire side of the graph automatically for you.